Today we'll be demonstrating how to enhance your work instructions using Mendix Low Code together with AWS Bedrock. This process streamlines the integration of technical specifications and instructions into existing documentation. The knowledge base stores and organizes technical documents which the large language model can access to answer questions to the process engineer and to help them create accurate work instructions. Our knowledge base can be extended by uploading machine manuals and instructions in various formats such as Word, Excel, text, and PDF. You can easily upload these documents to the Train the Model section of the application, where they are immediately added to the knowledge base. Let's get started. Meet Irene, a process engineer who is tasked with creating accurate work instructions for an automotive carburetor. Irene's first challenge is to incorporate the latest specifications of the F9D furnace into her work instructions. Normally, this would be a time-consuming task involving manual updates and checks. With the help of our AI-enhanced application, Irene can streamline this process. Let's see how. First, Irene uploads the manual of the F9D furnace to the knowledge base. She simply drags and drops the PDF manual into the upload box and presses save. With the manual now in the knowledge base, Irene navigates to the existing work instruction in the app and clicks Edit Work Instruction. She asks the AI a concrete question on utilising the manual to create work instructions for the furnace. Write instructions on how to use the furnace, include the highest temperature for melting metal. The AI utilises the uploaded document to create comprehensive work instructions. Irene wants the AI to merge the instructions with the existing instructions. For this, she prompts, "Merge the furnace instructions with the existing work instructions." The result is a merged version of the initial work instruction and the generated Furnace 9D instructions. She agrees with the results, and with a click on clear, she deletes the initial work instructions, and with the copy button in the AI assistant, the new version is added. In another task, Irene needs to update the work instructions for the generic laptop. The required manuals for the work instructions of the laptop are already in the knowledge base. Irene navigates to the generic laptop bill of process and edits the existing work instruction for the press setup. She asks the AI, "What is the oil capacity of the tool?" The AI automatically references the Atlas 15T press, as this information is already part of the work instruction. The AI utilises the knowledge base and returns the specific maximum oil level for the Atlas 15T. This information is exactly what Irene was looking for. She now asks the AI to add the appropriate step in the existing work instruction. The AI intelligently places the information where it is most relevant, ensuring the work instructions are complete and accurate. Again, Irene copies the updated work instruction using the included copy function and quickly edits the work instructions. Irene is tasked to change the laptop work instructions to Mandarin Chinese to use them in the electronics factory of her company in Shanghai. But her issue is that she does not speak Mandarin Chinese. Fortunately, she has an AI assistant to help. She prompts the AI, "Please translate all points of the existing work instructions to Mandarin." The AI returns the work instruction in Mandarin, and with a click of the copy button, the app adds the result to the English work instructions. The instructions are now multilingual. In our next task, Irene needs to generate work instructions for multiple tools and machines in the furniture manufacturing process. The tools, instructions and manuals have already been uploaded to the knowledge base. She starts with creating a bill of process with empty work instructions. She creates the header with the product information. Then she adds the operation. After that, she creates the work instruction with the title, the required tools, and the other machines and materials without specifying the work instructions. She continues to add operations and empty work instructions. Once Irene finishes creating the bill of process with the required headline, tools, and materials, she can use the auto-generation feature to create the content for the work instructions. She then initiates the auto-generation of work instructions for all the empty sections in the bill of process. The AI generates the work instructions based on the operation title, required machine, tools, materials, and the machine manuals from the knowledge base. Once the auto-generation is complete, Irene finds the AI-generated work instructions in the bill of process, indicated by the blue AI-generated tag. From here, Irene can edit the generated instructions and use the AI assistant in edit mode to refine the work instructions as needed. The AI has efficiently created comprehensive work instructions, saving a significant amount of time and effort. And that's it. You've seen how AI can enhance work instructions across different use cases. By integrating AI into your workflow, you can ensure accuracy, save time, and improve efficiency. Extending your knowledge base is as simple as uploading documents to the Train the Model section of the application. It would be great if we had the flexibility to easily create a chat pop-up for our AI bot, reusing our existing UI elements. Let's go to Studio Pro, add a pop-up page called chat_pop-up. On that page, we add a page parameter of the type work instruction, so that the chat has the context of the information of the current work instruction. Add a data view that uses that page parameter as a data source. And in that data view, we place the work instruction chat snippet. We can add some styling to the pop-up page. And let's go to the snippet and add a close page button so the user can close the pop-up. After that, we go to the work instruction edit page. Remove the chat container that we want to replace with the chat pop-up. Add a button. And select an appropriate icon and create a microflow that will open the newly created chat pop-up page. Next, we add some styling to the open pop-up button and rerun the application. We have easily created a pop-up for our AI chatbot by reusing existing components of our application.
The integrated circuit has been at the heart of many generations of modern electronics innovations and is driving the push for digitalization. As more businesses embrace digitalization, they consume and generate more data. This means increased demand for devices that can collect and store that data, and dramatic growth for semiconductors. Therefore, the role of IC design innovation in digital transformation will grow exponentially year after year. What does this mean for the future of product innovation? Siemens EDA, part of the Siemens Accelerator portfolio, where electronic innovation meets tomorrow. how do you manufacture products designed for an environment that doesn't exist in a lab or even on this planet? The companies in the aerospace and defense industry, the manufacturers designing individual aircraft components, or developing advanced and complex space exploration vehicles, face ever-present and constantly changing challenges. Demands are increasingly complicated, deadlines grow tighter, and stakes are higher. Aerospace and defense companies understand how critical innovation is to their survival. But innovation does not result from a single big idea. Real innovation requires a combination of intricate details and countless design, engineering, and manufacturing decisions. Real innovation requires digitalization. Today's leading engineers and design teams are building tomorrow's real innovations by digitally connecting the physical world with a virtual representation known as the digital twin. The groundbreaking concepts of the digital twin will tell you that something is happening. But innovation works when you find a way to connect product information to understand why that something is happening. This is called the digital thread, and it creates a seamless, multidiscipline integration between design, analysis, manufacturing, and support. When John F. Kennedy proclaimed that by the end of the 1960s we would place a man on the moon, they didn't have this technology to guide them. Paper designs, real-world simulations, and physical prototypes were considerable barriers stalling advancements, yet success was achieved. Tomorrow's aerospace and defense industries face the monumental tasks of building the products that require testing before implementation. Digital threads give opportunities of improvements in efficiency, productivity, cost, and agility across the entire organization, and the capability to test and validate in a virtual world. Once upon a time, JFK spoke of putting a man on the moon by the end of the decade and highlighted how the space exploration's infancy created technological achievements that sparked a great number of new companies and tens of thousands of new jobs. The sky was the limit. But now, the incorporation of digitalization has proven that the sky is no longer the limit. As major aerospace and defense industry leaders continue developing with digital technology, innovators can make greater strides in space exploration. Siemens helps aerospace customers achieve their goals by providing collaborative, synchronized program management across the entire product lifecycle and value chain.